Hey everybody, we're back with the Blackhawk by Roban, 700 size scale helicopter. Previous video I made a while back, I think last year. I expressed my experience where I crashed my other one, unfortunately due to a mechanical failure, and that was due to the balling rod ends on the main head coming apart in flight. It was a very cold day, but many of you guys have told me that temperature doesn't really make a difference. But essentially, what happened, these balling rod ends are very fragile. They break easy. I mean, just popping it off the actual balling causes them to fracture and crack. And I've noticed this when I was popping on a few of these, and I broke at least two. And I that was a red flag from the start. I should have put Align ones on these arms, but I didn't. I was so anxious to fly this thing. It was tuned properly, set up properly. Just mechanically, it wasn't too strong. I guess if I wasn't so hard on my cyclic, this thing would still be up and flying. But I can probably break this for you, and it'll crack if I even tried. Or here, let me show you guys if I can and demonstrate. I'm sorry, I'm gonna be doing this on the ground again. I did get a bench from my wife, but as you can see, it's being taken up by all my 700s and 550 and the 360. So I don't really have too much space there for now. I've been organizing all these helicopters as best as I can, but let's give it a go. Let me try to set this phone up quickly. So here's a broken one that I have of many of the broken ones I have in just the assembly stage. You can see it pops on too easy. You can see the fracture right there. Now, let me show you. This is a brand new one. And sometimes some of these are good, some aren't. But just popping them off causes them to break. And I'm not trying to say there's anything wrong with the Roban models. It's just I think their plastic in choice for their choice of plastic for the rod end, balling rod ends is pretty cheap. You know, it's kind of a hit and miss, but I feel like the last kit that I had maybe was on the shelf for a while, or maybe not. I don't know, whatever the case may be. See, this one already broke. Look, that one just broke on me right now, removing it. So we have two so far that are okay. This one's fine. Even the plastic feels a little more pliable and flexible. For those that break easy, the plastic actually feels harder and brittle. I feel like it's something in their mold, or I don't know, the way the plastic catalyzes or something, or cures. Here's another one. See, this one's good. You guys get the idea. So I went with the Align balling rod ends because regardless of how much I try to break those, I mean, the plastic's so flexible, rather cracking and breaking it stretches. It may just lead over time, over wear, and you might have play in the components, and they fit a little tighter, which is okay because it's a scale model and you kind of want it to hold its cyclic position. See, this is a brand new one. Let's see if this one breaks. There you go. This one did break. See that? So if you're transporting your scale helicopter, and let's say you're carrying it by the blades, and you might have tapped one of those blades and created leverage while the blades are on the installed on the main head, and you kind of pull on those servos with the blade on, that's enough to break them. And I think that's what happened. I carried it out to the backyard where I fly in the field, and I might have tapped one of those blades while it was already on the head, and I might have fractured one of those ball link rod ends, but you can see here's another good one of the good known ones. And well, actually this one also broke. There you go. Here, let's try another one. Maybe I popped on one of the broken ones already, but here's a good one that I couldn't break. Actually, look at that, it broke again. So now we have, I think all of these are broken now. Actually, we have one more. You can hear them snapping tight. See, this one doesn't break. No matter how hard I try, even putting leverage on it, it just doesn't break. And they're all brand new. These are, to me, toss these out and replace them for some Align servo horns. Use the ones that come with the TB70 kit, or replace them for it's the same dimension, same rod end, just Align branded, better plastic, or the ones that come for the Align 700L. Now I found with those, you can be very hard on the cyclic, and you run no risks on damaging anything on the head, or at least as far as it coming apart on you. And this is the old swash from that old kit. This is a brand new main head. And yeah, I mean, this is it was pretty sad that that's the reason it came down on me. I've never had a mechanical failure on any of my helicopters whatsoever. Not even the Aligns that they claim to have torque tube and, you know, umbrella gear issues. Honestly, by all means, in all honesty, I believe the Roban kits are made of high quality. The gears seem okay. I mean, if you run a good RPM and whatnot, everything the way it should be, these kits should, based off the way they're designed, should last you quite a while. You should do more inspections on these kits though. Why? Because it's heavier. It's not like your traditional 3D helis where, you know, everything's kind of just rigid. They're super light. You know, the power to weight ratio is just a night and day difference. So you kind of just don't want to compare the two. Treat this with respect and be more disciplined with the scale builds, because they do tend to be heavier, and of course they cost more, and they require more time to assemble and to get right. I do want to share my setup for this on my radio. That way any of you guys who are using the Spectrum electronics for the flybarless unit, the 6250HX, you guys can just copy and, you know, input the values in your radio and you know, start flying. I'll give you guys the PIDs and everything that holds. That way everything's, you know, perfect for you guys. Now I am running 1400 RPM on this. Last I checked, or it was about 1300, just because I like a more snappier tail. Now people say I should keep it at about 1200. I called Roban. Well, I contacted Roban through Z Hobby, and they contacted them. Turns out they're like across the street from them. Z Hobby is a Chinese distributor. That's who I get my parts from. So it's ZY Hobby. Contact them and you can buy parts from them for cheap or much cheaper. Or Motion RC, which also fulfills the same price. But as far as that goes anyways, they did mention that I can run a maximum of 1400 RPM and not to exceed that RPM due to possible mechanical failures. Now, possibly maybe the tail, not sure, but honestly I think that the higher the head speed, the happier the tail will be due to torque buildup, less pitch in the tail blades to achieve a holding tail, meaning there's going to be a less of a load on the actual gears. They'll spool up faster, but I feel that there's a less of a load on the torque tube and everything if you have a higher head speed. Also, it's easier on your batteries. It's more efficient for the motor to operate within its power band. So kind of keep that in mind. But of course, if you want to get this thing true to scale, you know, sound a little more realistic, the lower head speed would be nicer. The slower tail response would be better because it kind of moves like the real thing. So let me jump into the radio settings. Okay, hopefully my battery doesn't die on me. So let me set up and connect these servos because everything's disconnected as of now. So actually, give me one. Okay, so this is going to be very easy on the 6250. When installing the mechanics with the electronics already installed, disconnect everything from the flybarless unit. I have it installed right here at the bottom. Not sure if you can see that. And that is so that connectors don't hit on the way in and you don't pinch any wires. Otherwise, it will probably most likely won't go in. It's very simple. The servo, the middle servo, which will be your elevator servo, is going to go to the port number 3 on the flybarless unit, signal wire towards the top, or the terminals facing the passenger side of the helicopter. Oops, there goes my tail. The aileron servo on the left side will go on the opposite side, which is going to be on port number 4. This is difficult with the camera. And then you're running the smart ESC. You're gonna want the right side servo on the port number 1, and you would put your smart ESC if you're running an Avion on port number 2. Okay, let's install the receiver. I'm hoping to get a flight in, a maiden, once again, remaiden, or a maiden because this is a brand new kit. Possibly by the weekend. Gotta install the ESC now. Get this out of the bag. You're gonna want to use a pitch gauge for this kit for sure. I never do in my 3D helicopters. I don't feel the need to. I don't think it's not really, I mean, I always kind of just get a ballpark, so it's never really affected my flight performance. Not like it would on the scale helicopter. You don't want to go too much on the collective, too high, and you don't want to go too low. Otherwise, things will start to bind, and you'll have issues, and most likely leading to a crash and the loss of the entire aircraft. So let me get this last connector in here for the ESC, and the tail servo connects right to the 5th channel. But we won't connect that because I just want to demonstrate the cyclic. Okay, let me get the one second. Okay, so here's the telemetry running, displaying the battery voltage, but we're just showing the setup. So here you have the swash plate. It's leveled at 0 pitch. Now what I did this time while building the head, I put some bushings here. They're probably a millimeter longer than what they require for the length of this arm. But see that with this bushing is the same size all around, I don't have to worry about adjusting it. I lost about 1 thread into the the ball end rod link. The rod end. But see, now they're all even. I don't have to worry about adjusting those. Of course, if something's bent or not straight, then throw it off. But not enough to be noticeable. I doubt this is not isn't machined. Um, I guess the same. I'm sure they did a pretty good job. But anyways, they did, because when I put my blades, they all marked 0 pitch at center stick. I think somewhere I read they want 5 degrees pitch at center stick. I don't want to do that. With the little extra length, I was able to get my swash plate to come down a little lower for my 0 pitch on the actual blades, on the blade grips. And because of that, I do have more headroom, more travel upwards, which is okay, because that way now my servos aren't binding too much when I'm all the way at the top. So you don't have to do that. It should still work fine. And here's my servo throw. So I have, here's full pitch forward. I'm at, I think, 70 for the roll rates. So the swash plate moves a good amount. I've seen many people with their scale helicopters, their swash plate hardly even moves. Nothing binds, guys. Nothing binds. If you look at those arms, they're not at their full throw yet. Everything's good. So right here we're at 0 stick. We are at 3 degrees negative pitch, which is what the manual calls for. It's I think within 2 to 3 degrees negative pitch max, and 9 degrees to 10 degrees positive for the maximum pitch they recommend. 11 degrees would probably be okay now for me, because like I said, I dropped my swash plate a little lower, which gives me that leg room to go up 1 more degree. And before my swash plate starts to bind with the actual little these levers down here, because this is what actually starts to bind, because it can only throw it up so far before the swash plate stops traveling. And I'll demonstrate that right now. So if I'm at full pitch, full collective, that's 10 degrees that I measured. It's tilting backwards because it's in stability mode, but now that we're in idle up 2, it should be level. So we're at 10 degrees, 10.5 degrees positive pitch. You can see the arms, nothing binds. And I doubt nobody's gonna fly. The swash plate doesn't move this much in flight due to the actual airframe and the whole helicopter tilting forward. But see, on the bench, it will not bind. Nothing's gonna happen to your linkages. Nothing will pop off. Pulling back, you can see the servo throws are not excessive. Nothing's maxed out. Here's the link angles. Elevator arm does not touch the swash plate. See, if I wanted 11 degrees of pitch without these little bushing spacers that I put in there, when I would go full forward,
1 minute,
that swash plate and elevator arm would contact and pop that arm off. So that's why I had to do that. Not that I need 11 degrees, but I mean, it's good to have for those scary moments. I went ahead and made this elevator arm, replaced it for a steel one, which I made. That aluminum one kept warping on me on the previous kit. But yeah, here's my servo travels again.
20 seconds.
It doesn't contact my fuselage at all.
10.
And mind you, I'm keeping my full roll rates. Stock is 75 on this flybarless unit, but I knocked it down to 70. They recommend not to go below 60. I can go 75, but there's really no reason to. This helicopter's not gonna fly any. It's not gonna do any crazy maneuvers. But these links, for sure, they'll be more durable in flight under heavy cyclic or hard cyclic maneuvers, because they're more pliable than the Roban, than the ones that Roban provides in the kit. I just don't trust those anymore. They break easy, and it just sucks that I had to go through that. But it does make me feel better that it wasn't my fault. But here you have it again.
Minus 1 minute.
There's your servo. I'm gonna try to get the lengths of my rods and everything and measure them, and kind of just post it in another video. That way you guys just wanna, after my maiden, if you guys wanna just build yours based off these measurements, then go ahead by all means and set it up to the values I set mine up to. I've already flown the mechanic outside of the fuselage. It flew very nice. Just not within the fuse. I need to still try that. Out of the fuse, it feels almost like a 3D heli. It felt solid. Like I can throw it around. I can't loop it, of course, but I can, fly it around like crazy. Spin the tail around pretty fast, and give it some hard pulls on the elevator, or try to roll it side to side, and it was doing fine. I mean, it didn't come apart on me. But yeah, this is the mechanical setup, and I'm using those Spectrum H6350 servos. And what I did for my servo horns, I used the Spectrum, forget the length of the servo horn arms. I used some low profile ones for the front ones, and a slightly higher one, same length servo horn for the rear elevator servo. That way none of the links touch or interfere with each other. On the elevator arm, I installed this. I kind of machined the heads to be beveled. That way it doesn't contact the arm at all. I will demonstrate that again.
Minus 3 minutes.
It used to touch, not anymore. Here's a panic recovery function. Now let's go to the radio and show you the values that I have for the PID. So let's go to hold. Let's go to model setup. Let's start from the top. So you're gonna want a frame rate, of course, depending on your servos, most likely it's gonna be 11 milliseconds. For the IX12NX, it's gonna be hybrid 11/22 ms. It'll automatically detect what you have. And set it to automatic. Swashplate type is a 120. Just set it at, for the model setup, swashplate type, keep it at normal. Flight mode setup. Switch 1, switch B, switch to its inhibit. For your hold switch, H switch, and you want it to activate on position 1, not on 0. go ahead and bind it. Then we want to do the channel assign. This is going to be for your stability modes where you choose to activate it. So for aux2 is the only channel you need to assign. You assign it to flight mode. That way it knows that you have 3 flight modes because it's assigned to the flight mode switch, which is switch B, which we selected on the, where is it at? On the flight mode setup. So we know it's switch B, and we want the flight mode to be outputted on switch B. So there's a 3-position switch, and that way it knows when you go to forward programming to activate safe that you have 3 options where you can put it on the flight mode switch on every position in the switch. So now let's go to model adjust. This is what I have for the throttle curve, pitch curve, using the 120 amp Avion ESC, the E-Flight EFL 700 brushless motor, and using the 5000 milliamps a Spectrum 100C lipos. I honestly recommend with this helicopter use a heavier battery in the front, maybe one of those nice 6800 milliamp battery packs that Spectrum makes. Those new Basher packs, 120C, they run cooler, they're better, last longer, and also it'll get your CGs right. Or you'll have to kind of relocate your battery mounting locations, and that you can do it that way too. But I've seen people put weight or spare batteries up at the front cockpit to kind of correct the CGs, and honestly all that dead weight can be an actual battery pack that has more milliamps, and you'd probably be better off anyways. So pitch curve. Actually, let's go back. For servo setup, leave everything as normal. Don't touch anything there. Don't reverse anything. Everything normal. Throttle cut, you don't need that. Pitch curve is going to be the same for every flight mode and hold. I have 30, 40, I have 30, 40, 50, 75, 100. At 30%, I'm getting at 0 stick the 3 degrees that I need. At 100%, I'm getting my 11 degrees. Maximum, actually, well, of course, I actually have it reduced to 10.5 right now. But the max I can get out of this is 11 degrees. Without things binding too crazy. At 10 degrees, things are pretty happy. You get a lot of leg room with the mechanical components not having to interfere with each other. Where's my throttle curve? Throttle curve, I have hold, of course, is 0.
Normal.
For the first spool up, for normal, I have 80% just to kind of hear it out. Spool it up slowly. I'm gonna reduce that to 70 or maybe 65 just to spool it up for pre-flight check before I start flying. And then jump on to stunt 1, which is 100% on the Avion ESC. Dual rates in Expo, that's your preference. I have it on, I actually have it off, but I will put this on the, let's put it on the F switch, which would be right here. You have to assign the switch to every channel, otherwise it won't work. Or you'll have different toggles having to activate different functions. Let's do that first. For Expo, it's a heavy helicopter. You don't want quick responses from the servos. I feel like, you know, if you're running these Roban rod ends, any quick cyclic inputs, you might, you know, snap one of those in midair. I don't know. I haven't seen anyone complain about them, but I was at one case and I just demonstrated how easy they break. So let's go 25, 24. I hate even numbers. I don't like odd numbers. So let's go to elevator. Let's go to 24. Okay. So now that's for position 1. Oh, I should have done this on 0. Well, that's good because now I can, I guess, have my options. But let's do it on 1 because that's where on 0, that's where I actually fly. So let's do maybe 10, 12, 4, position 0. I actually want to fly this with Expo, that way I can feel the weight in the air. Kind of feel that slight delay just for realism. You don't want it feeling too robotic. Now I have 2 curves, and I can set up a third one, but I'm not going to. So there's your dual rates in Expo. Throttle curve, I already shown that. Gyro, you're going to set it to flight mode on your switch. Hold normal stunt 1 and stunt 2 75%. The channel will be gear. And then we go into forward programming for the final setup. Going to hold. Here's my swash plate. The roll. I have it at 260 frames per second. That's pretty fast, I know. It just depends. I mean, if you add Expo, you can soften that up and make it slow again. But you always have that resort where you can get that snappiness out of the servo if you move the stick faster or closer to the endpoints. Proportional for hold is 65, 85, 7. Well, I think that's the stock setting.
Normal.
Let's get out of hold. So proportional is 60, integral 60, derivative 20.
Timer start.
And I have it the same for every mode because I have 1
Normal.
RPM set. Pitch, I believe, is the same. 60, 60, 20. Agility 80. The lower you go on this value, the less robotic it flies in the air. For safe stability, your gain is going to be 50. The higher you go, the faster it snaps back to center and stable. If you go too high, it'll start kind of oscillating. The lower you go, the slower it snaps back to center, and it'll be more mushy. The weight will start to affect the stability function, and it won't stabilize as quick. So 50 is a good number. I mean, 40 is even okay because it gives it that weight in the air, that kind of a look that it's heavy. Envelope is the degrees of how far it will allow you to pitch and roll it. I'm at 65. That gives me a good speed, and you know, you don't really want to go too high, so I'm actually going to knock this one down to 60, just because you don't want anything binding, and you don't want to load anything up pretty crazy. So 60 is okay. Normal stability mode's on. We have it on
Timer start.
every mode
Stunt 2.
except stunt 2.
Normal. Hold.
It's also on hold.
Normal.
That way, as I land or hit hold, it doesn't flip on me, or for some reason tend to roll on me. It just keeps the position it's currently in, and it just never tips over on me on a takeoff either or landing. I do this to all my helicopters because I'm not a professional, so I use every resource I can. Attitude trim is pretty much I'm going to reset this. Oh shoot, let's go to 0. Wrong way. So if you're flying in stability mode or safe mode, as they call it, and you see that the model is drifting to the right, left, rolling left, rolling right, or pitching forward or back, and going in with either direction, roll, you go negative, it goes to the left, and you just kind of correct it and bring it into the center. What I like to do is just recalibrate the gyro to the position where the helicopter flies stable without moving. I have a video on that actually. So essentially what I'll do is, like, if I calibrate this Fusion 550, this airframe naturally leans forward, which is if I take off that way, the helicopter will naturally fly forward because it thinks that's level, because that's where I calibrated the helicopter. So I'll hover the helicopter just slightly off the ground where I can see the gaps and where it doesn't drift anywhere. And so then I use a wedge or something to kind of hold the helicopter in that position as I calibrate. And then as it flies, it'll stay in that position and it'll hold its position and it'll hover in a solid without moving or drifting. And that way you don't have to use any attitude trims. But that's your choice. I mean, that's just what I do again. So now set up swash plate on the 6250HX. For my servos are 33 Hertz. For the type, it's a 3 servo 120 degree. So it'll be, for the swash plate, I think is a second option. Here, let me show you one more thing. It'll say the letters A, C, and B in that order. Direction, you want to reverse output channel 1 and 2 and 3 normal. Oh, disconnected. That happens. It's okay.
Hold.
Back into swash plate. Subtrims should be at 0. Oh, actually, sorry. With the setup I did, try to get it as best as you can. That way you don't have to use too many subtrims mechanically. And then this is going to vary based on how you adjust your linkages. If I give you my measurements, and if you kind of put your servo horns 90 degrees as close as I did to where I did, then these numbers will work for you. But just play with this until you achieve zero interference in your setup, and then you have the negative degrees at a maximum of 3 at 0 stick and a positive 10 or whatever you choose. And then you have, okay, and in that state, in the subtrim menu, this will hold the servos so that you can install the servo horn at close to 90 degrees or 90 degrees. If you have programmable servos like torque servos, you can just recenter them with the tool that they have and get it exactly at 90. And you may not have to set any of these sub trims. We already covered all this. AFR, like I said, my roll and pitch is 70, which is good. I'm not limiting too much of my roll rates. The collective is 40. That's giving me my what was it again? The 10.5 degrees. Differential at 0. That's if you want to divide the pitch, positive pitch and negative pitch equally. So you want, if you're getting more positive pitch out of your setup, and you're like, hey, when I go down, my pitch is less negative. So then you would have to remove some, and then it'll kind of divide it equally. That's what differential does. But we don't need too much negative pitch in this case. Almost done here. Tail rotor, output setup. My frame rate is 560 for the servos I'm using. Direction, normal. Also depends on what side of the tail you mount the servo. I have it mounted towards the left side of the helicopter, which would be the driver's side, and on the opposite of the behind the tail. So, and I have the servo horn pointing towards the passengers. So you keep it as normal. Subtrim 0 or 18. My travels are 48, 28. Just kind of see it, watch it, make sure your lengths, it's just going to vary on the lengths of your arms. Make sure everything doesn't bind and it just travels the full amount. Phasing, I believe, is, yeah, it should be 0. I didn't do anything there. Okay. I think we're about done. Now we have throttle. You want to capture your fail-safes, 65%. So hover, guys, this percentage is so when you're taking off, the helicopter doesn't roll or apply any stability functions at 65% throttle. It'll just keep its position as if it wasn't in stability mode. Of course, it still won't roll it, but it won't start applying corrections for stability within this throttle range. So you want to capture your fail-safes at that throttle range. Complete. And gyro settings for the final one, orientation. I have the pins facing outwards, and just get the correct gyro orientation. I have position 5. And then you want to calibrate that. If you don't calibrate after choosing the position orientation of the fly barless unit, it will not save for the initial time you switch over. And then fly mode channel should be aux 2, gain channel gear, and output channel 6 is inhibit. I think that covers it all, so you should be good, guys, after this. And just take it easy, inspect everything, make sure nothing's broken or cracking or whatnot. Make sure nothing's looks like it's about to fail, because that kind of sucks. Let me see if I can show you my pitch before my phone dies. So I put it here on the head block, and I zero it to the head block without the model tipping over and moving on a stable foundation. So I get 0 now. Now I put it on my blade grip up at top. I don't do it with the blades because they are asymmetrical blades. So you go full positive. I'm getting, well, actually this is my swash plate level right now. Let me go to okay. Let's recalibrate this thing. Somewhere online I saw someone make one of these little contraptions to get these things, get the pitch right. So I'm at 9 degrees positive. Here I'm at 12.6. That's because the swash plate's tilting to one side. 8.6, 12.2. You can see the swash is tilting to the left. Let's see if we can get it flat. Let's see now. Yeah, so now we were getting our 10. I wonder if I have any trim set. No. And also you guys want 0 trims on this for helicopters. So here's negative pitch. We're actually at 3, but it's displaying 4 just because the swash plate's tilting to one side a bit. Here you are.
Timer start. -4 minutes. Set 2.
See if we can get an accurate reading now. There you go. So we're at 10. Should be close to 10 everywhere now.